Howdy, statisticians. So today we're looking at 3 different types of effects on the response variable. So of course we've talked about how a high correlation does not imply causation because I need to make sure that I'm doing an experiment. Okay, so one possible relationship between the x and y variables is called causation, which there's no lurking variable. And so the diagram would look like this. By the way, there's always a dotted line up above to show that there is a relationship or an association. And this arrow says that x directly causes y. So, a couple of examples. If I change the number of hours I sleep, so hours slept, that should directly cause how tired I am, so my tiredness. And I would draw it like this. Again, make sure I put the little dotted arrow over there so I show that there is a relationship between hours slept and my tiredness, but in fact the first one, the explanatory, does cause the response. Second example. So of course I'm sure many of you have experienced this problem. So the amount of water that's drunk, so H2O drunk, does in fact affect how many times I go potty. And again, I'll want to make sure that I include the relationship arrow connecting them. So on this next one, you need to actually white out, and since I don't have, oh maybe I do. Can I white this out? Oh, look at that. That's kind of cool. I didn't know I could do that before. So you need to white out that arrow. And what actually needs to be here is the relationship between x and y dotted. But here's what's happening. X does not, in fact, cause y. Instead, there is a lurking variable z that causes both of these to change. And so, examples, number of ice cream cone sales is positively associated with number of drownings. So it would look like this, where I have number of cones and number of drownings. We've actually talked about this one before. And so I do in fact have a very close relationship between those. But that's silly to think that the number of ice cream cones or ice cream cone sales is actually affecting drownings, right? So then we talked about this before. Oh, excuse me. What could be affecting them both? Well, some third variable, for example, like temperature. So temperature is making ice cream cone sales go up and number of drownings go up because it's hot and people are at the beach and eating ice cream cones. So therefore it's making them both increase, which causes that positive association. And then I look at letter B. So pumpkin sales in October are positively associated with candy sales. So pumpkins sold, definitely the more pumpkins I buy, I don't know about you, but I definitely want more candy. And of course that's silly to think that, so we have to come up with some other variable, and of course Halloween could make them both rise. Increases pumpkin sales and it increases candy sales. So my diagram would look like that.